Hello, can you hear me?
Yes, sir. Good evening, sir.
Yeah, good evening. Yeah. Okay, so just we are waiting 1 or 2 minutes for joining all of the participants, then we will start. Yeah. Okay, so now we'll start our today's class. So basically today we will try to discuss about that how we can easily make the land use land cover classification using machine learning in Google Earth Engine platform. How we can easily perform this analysis, and also a lot of things about that land use land cover classification, such as how we can easily calculated the accuracy assessment of this map, then consumer accuracy, then producer accuracy, then kappa coefficient accuracy, overall accuracy, then how we can easily calculate the area, all of those classes. So all of those things we will try to discover for today's class. So let's go. I simply start the recording. So now share the screen. So now can you see my screen?
Sir.
Okay. Okay, so let's go to today's class. Okay. Okay, so hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. So basically today is our sixth number of class, and today we are mainly focused the land use land cover classification using machine learning in Google Earth Engine platform. So first of all, we try to discuss about our course module for this today's class. So mainly today we'll try to discuss about that how we can easily make the land use land cover classification map using machine learning. So basically in this time we just talk about that supervised machine learning method, how we can easily perform the supervised machine learning method and make the land use land cover classification map. Then how to make the land use land cover classification chart. So basically in this time we are just calculating all of those area for specific classes and make the chart, then calculating the land use land cover classification area, then how to add the legend on land use land cover classification map, as well as we also try to cover the part for the accuracy assessment of this map, how we can easily check the accuracy such as kappa accuracy, then producer accuracy, consumer accuracy, and also how we can easily make the single class map. Suppose I want to need only for the urban map, I want to only for the cropland map, I want to only for the water body map. So this type of map, how we can easily perform in Google Earth Engine platform, we try to discuss about that. Okay, so let's go. So first of all, when you want to make the land use land cover classification map in Google Earth Engine platform, we have to just follow some process. Okay, and this process is the same for any types of land use land cover classification map when you want to perform. So first of all, you have to selecting your region of interest. Suppose you want to work with the Dhaka city. So first of all, you have to import your boundary shape file. So you have to select your region of interest. So this is the first step. Then second step is that you have to choosing and filtering the image collection. Suppose you choose the image for the land set and then filter this image collection. and how you can easily filter this image collection. We already covered the part for the Landsat or Sentinel, how we can easily filter and also get the satellite images. We already covered this part. So this is our second step. When you want to perform the land use land cover classification map, you have to choose and filter your image collection. If you want, you can work with the Landsat. If you want, also you can also work with the Sentinel, and both the process is the same. And then you need to collect the some training points. Suppose you want to collect some training point. In this time, we can collect the training point different way. Suppose you want to get the training point from the field, you can go to the field and take the GPS or coordinate about this field, and also collect the training point. Another way is that you can collect the training point from the satellite images. Okay, suppose from the satellite images we are using here the different types of spectral indices, such as or different types of band composition, and also collect the training point. Then we are also merge all of those training point together. Okay, suppose I want to take the training point for water body, I take the training point for the build up area, I take the training point for water body, I take the training point for the vegetation. Okay, then all of those training point I need to merge, and then I need to create the training data set by sample regions. So in this time, all of those training point I want to extract the pixel value, band pixel value. Okay, and all of those band pixel value creating a data set. Okay, this data set I want to separate two way. So suppose I want to use the 70% data for train my model and 30% data for test my model. Sometimes you can also use the 80% data for train your model and 20% data for test your model for accuracy assessment. And then we need to create the classifier. Okay, so we need to create the classifier and classify the image, and then create the classified image and display this result. And then we also check the accuracy assessment for using the confusion matrix table. We can calculate the accuracy assessment such as producer accuracy, consumer accuracy, or also overall accuracy. All of this type of accuracy we can easily calculate from the confusion matrix table. And finally calculated the area for each classes. Okay, so let's go try to show you the practical example, then you can easily understand about all of the process, how it will be work. So, okay, so I simply open my code editor. Okay, so I simply open my code editor. Okay, so in this time, first of all, I need to select my region of interest, which area I want to make the land use land cover classification map. So this is my first step. So here I already imported my boundary shapefile. Suppose I want to work with for this boundary, such as, okay, so I want suppose, okay, so I want to work with for the suppose Dhaka city. Okay, so here I already imported the Dhaka city boundary shapefile. So in this time I simply import that and work with for this land use land cover classification map. So just I simply import my boundary shapefile, and default variable name is the table. I change it, suppose ROI, and then give a variable name ROI, and now display the result. So I want to add a layer, so call the map.addLayer function and call the object is the ROI. And I also need to focus the center of this boundary shapefile. So use here the map.center object and call the ROI and zoom level suppose 10 and click the run. So now I got my area. So this is my boundary. For this boundary, I want to create the land use land cover classification map. Okay. Okay, so now this is my first step is the done. Selecting region of interest. Then second step, I need to choosing and filtering the image collection. If you want, you can choose the Landsat. If you want, you can also choose just Sentinel. Both the process is the same. So in this time, I want to work with for the suppose Landsat imagery. So simply go to the browse data catalog and click on the Landsat. I want to work with the Landsat, suppose Landsat 8. And mainly when you want to make the land use land cover classification map, then surface reflectance we are using. So I want to simply select the surface reflectance. This satellite image I want to use and then create this land use land cover classification map. Okay, so first of all, simply copy this art engine snippet for the Landsat 8. surface reflectance. Okay, simply copy that and then paste in my code editor and then give a variable name. Suppose this variable name is the LA. Okay, so now my image collection is stored in here. So now this image collection I need to choose. And then now I am to filter this image collection. And we already know a lot of process about the filtering about the image collection. Okay, so in this time I simply filtered this image collection. So take a variable name. So call my full collection and use there the filter bounds function. So it intersecting with my ROI. And then I simply use here the filter date function. And then put here this time period such as year of 2020, 1st January from suppose year of 2020 December 31. Then put here the filter metadata. I simply call this filter metadata such as cloud cover. Cloud cover less than 1. If you want to check how many images is available for this condition, simply use the print and use the image and use the size function and click the run. So I can get the total 5 images. If you want, suppose you want to work with for the single image collection, you want to work for the land use land cover classification map, then you can easily get the single image. You can get all of the image information about that. We already talked about for the second class, I think we also talked about that how can easily filtering the Landsat. So now you can see all of those total 5 images in here, and every images I got total 19 bands in here. Suppose you want to work for this image, which image is the acquisition time period is that 11th February 2020. Just simply copy that and display the image and work with this image. Okay, it's also okay, there is no problem. When you want to work with for the only for the single image, then work look like this. And then in this time I want to create the median composite. So use the median and then use the clip with my ROI. So in this time it create the total make a median composite from total 5 images and display the result. Okay, so now I simply show the result about this image map.add layer and call the object and click to the run. Okay, so I also add the comment about that. Okay, so first of all we can simply select our region of interest, then we need to filtering the image collection. Okay, so then we create the median composite and now I display the image in here. So I simply show the display. So click on here. In this time we are using here the band combination such as surface reflectance red, then green and blue. It is a true color composite and then simply 98% stress, and now simply display the result. We can get this color image look like this. Okay, so we can get the image look like this, you can see. Okay, so now I simply import that, simply copy this variable name and then paste after the object name. This is the object, simply paste here. Okay, so now this is our second step for choosing and filtering the image collection. I choose the Landsat 8 and then filter this image collection. You can choose the Sentinel and filter this image collection. Okay, so now I can get my satellite images in this time. Okay, so in this time from this satellite images I need to collect some training point. Okay, and for when you want to collect the training point, then we are using the different types of band composition. So then it will be showing the different types of feature easily. We can easily identify this is the build-up area, this is the vegetation, this is the water body. This type of class we can easily identify from the scenario images using the different types of spectral indices. So for that, in this time you can see this is my satellite image. This satellite image, I want to collect some training point. So in this time, when you want to show the satellite images, we can easily identify this is the water body. Okay, and this all of this the build up area. We can also get some, this is that barren land area. We can also get some vegetation. Okay, this is the vegetation. The vegetation region. Okay, in this time I use here this band combination. You can see this band combination is that red, green and blue. If I want to use it, suppose near infrared, then use here the red and then use here the green and also increase this 98% and apply. So now I can get the image look like this. Mainly when you are using this band combination 543, then I can get this water body as a black color all time for any region. Okay, so when you want to use this band combination 543, then we can get this water body as a black color. Okay, so this is the black color, you can see this is the black color. Okay, and dense vegetation we can get the better red color. Okay, so this is the dense vegetation area, red color, better red color, better red color, red color, it is dense vegetation. Okay, so this is another band composition. So when you want to identify the vegetation or water, in this time water look like as a black color and vegetation look like as a better red color or dense red color. It's identify the dense vegetation. Okay, as well as you can also use the other types of indices, such as you can see this is the water body also in here, also water body black color. Okay, also water body, also water body. Okay, we can easily identify. Also you can see this is the dense vegetation red color in this region. Okay, suppose in this time I want to use at the 6 and use at the 5 and 3 and apply it. Okay, so mainly we are using this band combination for identify the barren land. Such as you can see, you can easily identify barren land look like is the brown color. So this type of brown color region, you can easily identify the brown color. Okay, so this type of region you can see brown color region. Is it the barren land? Okay, so this is the barren land. This is the barren land. This is the barren land. Okay, so 653 we are using for that for identify the barren land, as well as we can identify the vegetation. You can see this is the vegetation. Okay, this is the vegetation. Okay, this is the sparse vegetation, this is the dense vegetation, we can easily identify, and this is the water body as a dark color, we can get this. Okay, so also you can see the barren land, we can also find out in here. Okay, okay, suppose a lot of indices we can easily use for the different types of then composition we are using and take the training point. Suppose you want to make the land use land cover classification map, you want to create for the unknown place, which place you did not visit the physically. Okay, then we are using here the different types of band composition, and then we can identify the different types of feature. Okay, so basically different types of band combination we are using for identify the different types of feature. So in this time I can easily identify this is the water body, also this is the water body as a black color. So so I simply take the training point from here. So let's go how we can take the training point. So for getting the training point, simply click on here, you can see the add a marker, click on here, then you can see geometry will be added, simply click on here, and now put here suppose water. Okay, water, and then feature collection, put the property name. Property name will be same for all of those classes. So I put the name suppose as a variable, suppose class. And for water body, I set the value as a 0. So all of those training point of water body, I set the value as a 0. So then click to the OK. So now we simply take the training point from here. This is the water body. And this is a supervised machine learning method. So that's why we need to make this type of training point. For the pre-categorized data, we need to include it in here. So I just simply take this training point. Also, this is the water body. Also, we can get the some water body in here. Suppose I take the turning point for the water body. Now I take the another turning point, suppose for vegetation. Just simply click on here and click the properties. So I put this property name, suppose vegetation, and then put the feature collection, then property name is that class, and set the value for 1. So all of those vegetation turning point including in the 1. So click on here. So I can simply take this turning point for the vegetation. Okay, so when you make any mistakes look like this, so simply click on here and then delete that. Okay, and then also take this turning point. So simply select this marker and select the vegetation which turning point you want to need. Simply select that and then also take this turning point. Okay, so now I take the another turning point, suppose banner land. So simply click on here and then banner and put the feature collection in property will be class and set the value for 0, 1, 2. Okay, so first of all we can take this turning point for the water 0, then 1, then 2. Okay, so I simply take this brown color. You can see the brown color is that barren land. Okay, then we also take the turning point for build up. Okay, then simply click on here. Property will be class same, and in this time it's 3. Then okay. Okay, so now in this time all of them are build up area. I was simply change the band combination, then it also better for identify the build up area. Suppose I would add the two color composite. So for red, then green, and then blue. Light. So now we can take this turning point for the build up. Okay, so now we also take the training point for the build up. So in this time, I have to classify it from the satellite images such as water body, vegetation, build up, and barren land. So for that, I take this training point according to my classified classes. So now this is my third step. My third step is that I need to merge of all those training point. Okay, so for the merge, I simply take a variable and put the variable name, suppose sample. Okay, and merge all of those training points such as water. It merge with suppose vegetation, and then it also merge with barren, then merge with build up. Okay, so I simply merge. So now let's check about our training point. So simply print that. Print this variable sample. Then click to the run. So now it displays the result about that. You can see we can got total 198 training point. Okay, from all of those training point, we can get total training point is that 198 training point. And if you want to check about the training point, suppose you can see it will be start from the 0 and then up to 197. Okay, 197. So all of this training point, and we already mentioned that which training point is which class. So if you want to check it, suppose 6 number training point, this class is that 0. Okay, and this coordinate is that. Okay, suppose also you can check the other training point, suppose 45 number training point, what is that class? You can check it, this class is that 1. And what is the 1? 1 is that vegetation and 0 is the water. So all of those data we pre-categorize look like that. Okay, so you can see this was 78 number training point. What is that? You can check it, class 1. Okay, so class 1 is that vegetation. Okay? All of those training point has including their class name number. You can see 3. So 3 is that, what is the 3? 3 is that barren land, build up area. Okay, so because you can see when I take this training point, I put here this 3 for their class value. Okay, so 3. So in this time, I merge all of the training point and store it in a variable. Okay, in this variable, I store it. Okay, so in this time, all of those training point, I need to extract the band pixel value. Okay, so basically this is my data set. I want to extract the band pixel value. So for that, I need to create a variable, suppose bands, and in this variable, I stored all of those band name, which band I want to use for extract the pixel value. So I want to make a list. So I want to put in mention here the suppose SR B1, then also put here SR B2, also put here SR B3, also SR B4 red band, also SR B5, then SR B6, also put here the SR B7. Okay, so if you want to check about all of the information about the band, simply check here. You can see band. Okay, so I take total 1 to 7, all of those band. I want to extract the band value from here. Okay, and this band value is that my data set. Okay, so let's go about that. How can easily extract the band value? So for extracting the band value, we are using a function. This function is that sample regions. So okay, so for that, I take a variable. Suppose this variable name is the training, and then I simply call my image. Okay, so I simply call this image and paste here. From this image, I select only for those band which I listed in here and store it in this variable bands. Okay, I want to extract the band pixel value, so that's why I need to use the function sample regions. Sample regions. Okay, so I simply put all of those argument and then make a dictionary in here. So curly bracket start, and also curly bracket end. So first of all, collection. Collection is that all of those sample, all of those training point. Okay, this is my collection. In this time, total 198 collection, and it is stored in this variable sample. Simply copy that and then paste here. Then properties. So properties is that all of those classes property name is the same class. Okay, so in this time I want to use here the properties. So make here the square bracket and put the property name class. Okay, then scale is the resolution, such as 30-meter resolution. Then it's not it, I simply remove that. Okay, so now I simply print that about this data set. Simply copy and paste and click to the run. So now it extract all of those point band values. Suppose every single point I want to get all of those band value. Every single point I got all of those band value. Okay, so we can check it from here. Suppose because we can get all of those point in here. Okay, suppose for 100 number point we can check. We can get total 8 properties because here I mentioned the total 8 band. So click on here, then we can get all of those band values and also their class. Okay, for the class 2 you can get all of those band value. Also you can see this for this class 2 I can get all of those band value. So every single point we extract these band values, and these band values is my training data set. This is my data set. Okay, so now this data set I want to use, suppose 70% data set for train my model and 20% data for test my model for check accuracy assessment. Okay, so in this time I want to divide this data set into two way. So in this time some person also use for the 80% data and 20% data, this ratio. Also some paper can also see that 70% data or 30% data. Okay, so it's different, vary from. So in this time I want to use here the suppose 80% data for train my model and 20% data for check my validation. Okay, for checking the accuracy we divide the data set two way. Okay, so here all of those data set is stored in here in this variable training. Okay, this variable I want to divide in two way. So 80% data and 20% data, and these things we can do the randomly. Okay, so I want to randomly some data set. Okay, and also for the training, and also take the some randomly data set for testing. Okay, so in this time for the randomly, when you want to take the data set randomly, then we need to also use here the another function. This function called the random column. Okay, so this random column mainly when you want to take the data set randomly. Okay, then we are using the random column function. So take a variable. Suppose I put this variable name is the train data. Okay, and all of those data is stored in here in this variable training. Okay, so I simply copy this variable name and paste here and use the function random column. So basically this function distribute the data randomly. Okay, so I apply the random column function and store it in this variable train data. So basically all of those randomly data is stored in here. Okay, so now I simply divide this data two way randomly, 70% data or 80% data and 20% data. Okay, so let's go about that. So take a variable. Suppose I put this variable name is that train data. Sorry, train set. Okay, so I use, and this time I have to take the data for, I also write the suppose 80% data for using training the model. Okay, so I simply take this variable train set, and this 80% data set come from here randomly. I already used the random column function, so now I can get the data randomly. So put here and then filter it, filter, and use the art engine filter less than random 0.8. Okay, so now it's selected for the train set. and we also use the 20% data, rest of the 20% data for using validation or testing. Okay, testing. Okay, so now take another variable, suppose test set, and also call the train data. This train data I filter, so filter search engine filter, use at the greater than greater than or equals random 0.8. Okay, so now it's also distributed the another data set for the 80% data set, 20% data set for testing. Okay, so now this data set, train set, I use for train my model, and this test set I use for check the validation. Okay, so in this time I want to create my model. So in this time, okay, so anyone any question? Yeah, please. Yeah, please.
Understand here you take less than 0.8 and also greater than and equal than 0.8.
Okay. So in this time here you can see here I use at the less than. So randomly less than 0.8%, and also get at the all of those rest of this 80%, which data is available, 20% is available. So use at the greater than or equals 80%. Okay, so it means that it will be take the 20% data and it take the 80% data. Okay, so in this time when you want to put it at the 0.2, then it will be wrong. Okay, some person also use it for that. So because in this time I use it the greater than or equals. Okay, greater than or equals 0.8. It means that 20 or 0.2.
Okay.
Yeah. And then also, okay, how many features collection should we select? Okay, so basically in this time we take the training point, it's depend on our region, and also it's depend on our accuracy. Suppose in this time here I take the training point, such as you can see I put the training point for build water with 37, vegetation 48, 44, 69. Okay, so in this time, this region I take this training point, look like that. Okay, suppose when I want to work with for the whole country boundary of Bangladesh, then I also need to increasing this training point. Okay, and when I face any problem for my accuracy, I did not get the better accuracy, then I also need to increasing this training point for get the better accuracy. Okay, so but for this small region we can get that training point more than 30. More than 30 is the enough for the small region. But when you want to work with for the big region, so it's depend on our accuracy. If you did not get the better accuracy, then you have also need to increasing the training point. Okay, and for the small region, 30 more than 30 number of training point is the okay, there is no problem. Or if you also get the less than 30, also there is no problem. Okay, so basically when I check the accuracy and I did not get the better accuracy, then I also need to increasing this training point. So any question? Yeah, please.
Yes. My question is regarding about how did you enable your pointer in order to select the sample? Before selecting the sample, water, building up, all this, yeah. How did you enable it? I didn't follow this part.
Okay. So basically when you want to select this, so first of all, okay, so I also remove all of the things from here. You can simply click on here, you can see marker. Simply click on the marker, then you can see, suppose water, you can simply click on go to in here and put this your name, your class name. You can use any name, there is no problem. In this time I want to get the training point for the water, so that's why I simply put here the water. Then import as feature collection and set here the class property name will be class. Okay, and it's also variable. You can use any name, and this name is the same for all of those class. When you want to take the build up area, it will be same class. Water will be same class. All of the things, and also set the value. So I set the value for the 0 and then okay. Okay, and then take the training point for the water body. And when you want to take the training point, then we are also using here the different types of band combination for get the feature properly. Okay, so we are using here the different types of band combination from here, and we can easily get the feature about the this is the water body, this is the vegetation, this is the barren land, this is the dense vegetation. So we are using here the different types of band combination from here. Okay, and using the different types of band combination and take the training point from the satellite images. Okay, for all of those classes. Yeah, is it clear?
Yes. Thank you.
Okay. Okay, so statistical analysis issue as we are taking the sample point for feature. So in this time it's depend for suppose some person also use at the 80% or 20% or 70% or 30%. Okay, so it's different. Okay, for the region other things, but 80% 20% is the most of the paper. I follow that research paper. They're mainly they're using at the 80% data for train their model and 20% data for their use for checking the validation. Okay, but also okay if, when you want to work with the 70% and 30%, it also okay, there is no problem. Okay, that's it's a ratio about that how many data set you are using in here. Okay, so in this time we can get the data set, all of the things we data set. In this time we create the classification model, and using the classification model we are using here the lot of model. If you want, you can use here the random forest. If you want, you can use the classification equation trees. So let's go, we create a classification model about that. So classification